All right, a little bit longer equation. Okay, now we've got two reactants and two products. This is called a combustion reaction. Combustion reactions are recognizable by having oxygen as a reactant all by itself, and the products, carbon dioxide and water, both contain oxygen as well. Okay, so in our inventory, we're going to have carbon, hydrogen, and oxygen. And if we take our inventory, we've got one carbon on the left, one on the right, 4 hydrogens on the left, 2 on the right, and 2 oxygens on the left, 2 plus another 1 for 3 on the right-hand side. So the carbons aren't out of balance, so we're obviously not going to start there. So we've got a choice between hydrogen or oxygen. Here's where one of those tips that was in the video on balancing equations comes in. If you have an element that is in more than one location, such as oxygen, it's in both products, and it's also by itself, okay, both of those occurrences are clues that are suggesting that you should leave that element for the end. A couple of reasons. One, if it's in multiple formulas and you're trying to balance it, how do you know which formula you're supposed to put the coefficient in front of? Okay? The other part of that is that coefficient not only affects the oxygen, but it also affects the other element as well. Which is why having an element all by itself is such a nice thing as well to have at the end, because it kind of acts as cleanup. When everything else is balanced, then you can come here, add one number, and it cinches up that last element all nice and neat. So we're going to leave oxygen for the end. So if we've got 4 hydrogens, on the left, 2 on the right, that means we're going to need 2 waters. That's going to update us to 4 hydrogens, but it's also going to affect the number of oxygens. So there's 2 plus another 2. So now we're at 4. Carbons are balanced, hydrogens are balanced, so now we've got to deal with the oxygen. So 4 on the right, 2 on the left. We can use a coefficient of 2 in front of oxygen to give us that 4. Everything's balanced, so we have a balanced equation. Okay. Quick sidebar on this one. Let's just say that we balanced this and we ended up with coefficients of 2, 4, 2, and 4. Right? Now, if we consider those, would it still be a balanced equation? 2 carbons on the left, 2 carbons on the right. 8 hydrogens on the left, 8 hydrogens on the right. 8 oxygens on the left, 2 times 2 is 4, plus another 4 is 8 oxygens on the right. So yes, this combination of coefficients would give us a balanced equation, but it's not in simplest form. Just like ionic compounds, when we did the crisscross method for writing the formula, we said if it can be reduced, it needs to be in simplest form. The same applies to coefficients in a balanced equation. Make sure it's in simplest form. Okay? All right, another combustion reaction. Okay, a little bit different spin on this one. So we're going to tally our carbons, our hydrogens, and our oxygens. And so we've got 2 carbons on the left, 1 on the right, 6 hydrogens on the left, 2 on the right, 2 oxygens on the left, and a total of 3 on the right. Everything's out of balance. We're going to leave oxygen for the end because it's by itself and in more than one location. So let's start with carbon. If we start with carbon, 2 on the left, 1 on the right. So we're going to put a 2 in front of CO2 to give us 2 carbons. That changes our oxygens. 2 times 2 is 4, plus 1, so that updates to 5. Still leaving oxygen for the end. So let's go to hydrogen. 6 on the left, 2 on the right. So that means we're going to need 3 waters. 3 waters gives us 6 hydrogens, but it gives us 3 plus another 4 oxygens, so it updates to 7. Right? So now carbons and hydrogens are balanced. That leaves only the oxygens, but now we've got an issue. The issue we have is that we have an odd number of oxygen atoms on the right side, but on the left side, the only source of oxygen is O2, diatomic oxygen. So it's kind of the Twix syndrome, as I like to refer to it. You know, they come in a 2-pack. All right? There's no whole number you can put in front of oxygen that's going to give you an odd number of oxygen atoms. Okay? Just like when you buy a Twix bar, you're only going to get them in multiples of 2, 2, 4, 6, 8, 10, etc. So, easiest way to clear out an odd number, remembering the fact that we're dealing with coefficients which are multipliers, easiest way to make an odd number even, multiply it by 2. So what we're going to do is we're going to pause the balancing, and we're going to go back up to our equation. And for every formula that has an element that's already been balanced, we're going to double the coefficient that's there. So here, carbons and hydrogens are both balanced already. There's nothing there, so it's understood to be 1, so we're going to double it to a 2. Okay? We're doubling all the existing coefficients. Oxygen has been balanced, so we're going to skip over that. Okay? Carbon dioxide has C, that's been balanced. So let's double this to 4. Water has hydrogen, which has been balanced, so we're going to double the 3 to 6. Okay? When you change your coefficients, update your inventory. 2 times 2 is now 4 carbons, 2 times 6 is 12 hydrogens. Over here, 4 times 1 is 4 carbons. All right, we haven't dealt with the oxygen yet, so skip over that. 6 times 1 is 6 hydrogen. Or, I'm sorry, 6 times 2 is 12 hydrogen. So you can see, because we doubled everything, we've raised everything proportionally, and so we have the same formulas, okay, or we have the same balance. Now we look at our oxygens, okay, we have to update that as well. 4 times 2 is 8, plus another 6 gives you 14. There's your even number, which will work very nicely with diatomic oxygen. So use 7 for your coefficient, which gives you 14. And now all your elements are balanced, so your balanced equation would have coefficients of 2, 7, 4, and 6.